Hi all, good evening. So yesterday we discussed about what is virtual private cloud. So let me explain again. So AWS virtual cloud is a virtual environment where you can set up your data center, or you can set up, you can say, your LAN, local area network, and you can set your local IP addresses and configure your local IP addresses for your instances. There will be no, like you can say, no physical hardware will be given by Amazon. Everything will be in virtualized environment, and they will provide you the logical router, you can say logical local area network to you. So you have to just select all those IP ranges, and you have to also configure your router, you have to configure your route table, also need to configure your subnets, VPC, everything you have to configure. And that environment, that VPC environment will be local, like no one, no other customer can contact to you unless you have allow them. So everything will be like a secure environment. So your systems can communicate each other, and but that all those environment will be secure from outside, and no outside people can communicate to your instance, or they cannot enter into your environment. So you have to provide some rules so that they cannot enter, right? So it is similar having your own data center, and this is logically isolated from other VPCs on AWS. Suppose you are created more VPCs, maybe 5 VPC, 10 VPCs, and each VPC having their own isolated environment. So your VPC 1 cannot communicate to VPC 2, but if you want, then you can make some agreement like some peering connection or maybe some transit gateway. So using that you can connect. Otherwise, by default, they will not communicate each other. So you can have one or more IP addresses, subnets inside the VPC. So you can create some subnets. I'll show you how to create subnets and how to configure your IP ranges for your subnet as well as your VPC. And
What, sorry, what did you say? Can I have more than one VPC? Can
yes,
someone?
you can have more than one VPC in one region, and there are many regions. So you can create like there is some limit. There is the soft limit is 10, so you can create some 10 VPC in one region, but you can increase it. You have to send one mail to AWS so that you can increase your VPC. Means that is not means you will only create one. You can create more. So per region basis, the soft limit is now is 10.
Okay. Why would someone want to have more than one VPC? I mean,
See, suppose you are having many departments, right? And you want for every department you need one BPC, like your maybe your customer having. Suppose you are having one university and you are designing your VPC for your university. So there may be different sections, right? And maybe your admin section having one BPC, they will communicate. Their instances will communicate, or maybe your there will be some PG section or MTech section, or maybe physics department. So for as per your requirement, you can create those VPC. Suppose you are having some science department, you will create one VPC for science department, and inside you have to create some subnet for maybe physics, one subnet for your chemistry, one subnet for your mathematics. Like you can also create. And suppose your owner having not only one college, maybe they are having medical college, they are having engineering college, maybe they are having other universities, and they also have other companies as well. So all the softwares will be deployed to suppose in AWS. So definitely they want different VPCs for their different companies, right?
okay.
And one VPC is confined to one AWS region, and it does not extend to a region. But one subnet is specific to one availability zone. A subnet cannot expand to more than one availability zone. This is specific, but in one availability zone you can create multiple subnets. So we'll discuss that. So the basic component of VPC is CIDR, CIDR, CIDR block, and IP address subnets. One implied router. Implied router is, you can say, some one router, you can say this is a logical router and responsible for your routing between your subnets and also your VPC, and also your instance will communicate to outside also VPC. So all those rules will be added to these route tables, and your implied router will read those route tables, and accordingly it will fix your routing of your instances inside your VPC. Next is internet gateway. Internet gateway is one gateway that is from AWS to communicate. Your instance can communicate to outside world. So they will get internet connection, you can say, from the internet gateway. Using the internet gateway, they will communicate to internet. Next is security group. Security group is one level of firewall that will be added to your EC2 instance level. In the security group, you should configure who should access my EC2 instance, or how my EC2 instance should not should not go outside this range of IPs, and from outside people who all are able to access my EC2 instance. Those rules will be provided in the security groups, and the security groups will be instance level, and it will be added to your EC2 instance. And next is your network access control list. This is also another security firewall, you can say, and this will be added to your subnet level. But those rules is different security rules of your security group and network ACL also, those are different. We'll discuss in detail that. So let's see what is VPC types. So when you open your browser AWS account and search this VPC, this is the VPC dashboard. If you search VPC in the search button, you will see one VPC service, and this is the VPC. And if you select any region, so one default VPC will be provided by AWS. This is the default VPC. If you click this VPC, you will see one VPC here. This is the default VPC. Right. And additionally, you can create new VPC. You can create new VPC, and for this you have to provide some IP range and some name. Let me explain what is the difference between your default VPC and your custom VPC. Default VPC is provided created in each AWS region. For each AWS region, AWS provided a default VPC for you, and for that has a CIDR block. CIDR range is this one. This is the CIDR block. I will also explain what is this. And apart from that, you will get a security group, a default security group, one network ACL, one route table settings, and also has an internet gateway by default. This is very important point. In the default VPC, one internet gateway provided by your AWS. But if you create your custom, this internet gateway was not there, so you have to create your own internet gateway for your custom VPC. So for the custom VPC, is a VPC and AWS account owner creates. So you are responsible to create one custom VPC for your usage. AWS user creating the custom VPC can decide the VPC CIDR block. So you have to provide the CIDR block, the IP range of your VPC. Has its own default security group, NACL and route tables. You can update this route table or your security group. Does not have an internet gateway by default. One needs to be created if needed. So if you need, you can create your internet gateway. So let discuss about implied router. So what is implied router? Implied router, this is the implied router, right? And the implied router responsibility is routing your traffic to maybe inside your subnet to subnet, instance to instance, or you can um, communicate to also outside your VPC. So it is a central routing VPC function. VPC routing function. This is. It connects the different edges together and connect the VPC to the internet gateway and virtual private gateway when configured. Each subnet will have a route table. Then that the router uses to forward traffic within the VPC. So as per your route table traffic rule, so accordingly your router will decide whether I have to route or not. The route table can also have entries to external destination. So this is, in this example, this is one destination like 10.0.0.0 by 16, and this target is local. That means this range of IP address can communicate each other, and there is no communication to outside world. For the outside world, you have to add another entry point. So I will tell you. So route tables, I'll show you what is the route table. Here is one route table. This is the by default route table, and okay, this is uh, 1 minute. Let me delete this. I have created for other purpose.
Bit slower.
Hello.
Can you please go a little bit slower?
Okay, okay, okay. This is the default route table. This is provided by created by AWS. I have added some route rules, but this was the default one. This was the default one. 172.31.0.0 by 16. I can select another one, another region. Actually, I have modified that. Maybe North Virginia. I'm selecting North Virginia. This will be very default. Not found. Oh, sorry. Searching using that ID, right? Yeah, I selected OYO region, and for the OYO region, let's see. This is the VPC, and this VPC having 3 subnets and 1 route table. Let me see the VPC, and this is the VPC, and the range is 172.31.0.0 by 16, and the route table is like this. Yeah, this is the route table, and here 2 rules has been provided. One is this IP range, target is local, and status is active, and next rule is 000 by 0, and the target is internet gateway. And that means this IP range, I'll discuss about this IP range. This IP range can communicate each other, and this is the target is local. That means your local EC2 instances can communicate each other. This routing is allowed, and this is by default. You cannot delete also. This is a compulsory rule for your route table. You cannot delete this. That means in your VPC every EC2 instance can communicate each other. This is the first rule, and the second rule is this IP range means every IP can communicate the target internet gateway. So from the internet gateway, you can communicate to your instances, or your instance can communicate to your outside world to any IP, right? So I will discuss about this IP range so that it will be get clear. So route table, each subnet must be associated with only one route table at any given time. Right, each subnet have at least one route table. If you do not specify a subnet to route table association, the subnet when created will be associated with the main VPC route table. You can change the subnet association to another route table. So you have to create one route table. If not, then your subnet will refer to your default route table. So please don't delete your default route table. Or you can suppose you change, you can also change. Suppose you want to delete the default route table, you have to create another route table and make the second route table as a default. You can also edit the main route table if you need it, but you cannot delete the main default route table. So your default route table will not be deleted. However, you can make a custom route table manually and become the main route table. Then you can delete the former main. as it is no longer a main route table. So at any point of time there should be one route table, and that route table should be a default one. Every route table in a VPC comes with a default rule that allows all VPC subnets to communicate with one another. So the first rule I showed, that should be allowed to communicate with one another. Your EC2 instances inside a VPC can communicate with one another. You cannot modify or delete that rule. That rule cannot be modified. I'll show again. This is the default rule, and this rule cannot be deleted or cannot be modified. And this rule means your local systems can communicate with each other. This is my IP range. So let me explain about IP range, IP addressing. So VPC IP addressing. The CIDR block is the range of IP addresses that you choose for the VPC when you create it. So once the VPC is created, you cannot change its main CIDR block, right? So while creating one VPC, you have to provide one CIDR block, and that CIDR blocks mean that IP range. You have to provide the IP range, and once the VPC is created, you cannot change the main CIDR block range, but you can expand. Suppose you have provided one IP range and you think that maybe I need more IP for my instances, so you can expand, but you cannot modify your current IP range, the created IP range. If you need a different main CIDR block range, create a new VPC. The different subnet within a VPC cannot overlap. So let's discuss about what is the IP range, and how we can assign those IP range to subnets and VPC, right? So while creating one VPC, suppose I'm going to create one VPC. The first point is your VPC name, maybe my VPC, right? And C second is one CIDR range, IPv4 CIDR manual input, right? And either you can create IPv4 or IPv6 maybe. Okay, let me show you IPv4. So IPv4 is like this. No, yeah, 0.0.0.0. This is right. IPv4. You can say the IPv4 address is a 32-bit address. The first is 8-bit, and this is the 8-bit, and this is the 8-bit, and this is the 8-bit. So if I show you in a some good architecture, so you can say this is my IP, and this is some 8-bit, this is 8-bit, and this is 8-bit. Total 32-bit, right? And you can say this is 8-bit, right? So in the 8-bit, how many addresses is possible? You can just think about our digital electronics, or how we are digitally stored, like 0 and 1, right? And in the 8-bit, how many address can be stored? So suppose 1 bit is given to us in the computer science. If you 1 bit is given to us, 1 bit. So how many data will store? Either you can store 0 or 1, right? 0 or 1. Similarly, if any 2-bit is given, this is for 1 bit. Total address, total will be either 0 and 1. The total address is 2. One is 0, one is 1. If I given 2-bit, so what is the result? 2-bit. 2-bit mean either you can store for the first bit 0 1, or sorry, 0 0 0 1 1 0 1 1. So I can configure how many address? 4. if I taken 3 bit, so what will be my configuration? Like 000 001, similarly 0010 011, then again 100 101 110 111. So how many? 1 2 3 4 5 6 7 8. So 8. 8. Then is it clear or any
Yeah.
doubt here?
No, it's clear.
Okay. So similarly, if you take 8 bit, can you tell me how many address is possible for 8 bit?
2 to the power 8.
Okay, 2 to the power 8 is 256. So our range can be start from 0 to 255.
Yes.
0 means all bit are 0, 255 means all bit are 111, right? Okay.
Yes.
Then here, if I go to my IP address, suppose 0.0.0.0.0. So the last bit can be maybe 0 or maybe 1, maybe 2 or maybe 3, like maybe 255. And similarly, this bit also 0 to 255. Like, and if I ask someone how many IP will be possible, the total IP, you can say, okay, 256 for first and 256 for second, 256 for third and 256 for fourth. So if I multiply everything, the total will be like 2 to the power 32. That IP address range will be possible. To the power 8, yeah, 16, yeah. This range will be possible, right? And we'll go to our VPC range. There is some RFC 1919 range for our private IP address. So that range will be like your this is support like 10.0, and this IP ranges 10.0.0 by 16, then 172.31.0.0 by 16, then 192.168.0.0 by 20. So this range of IP is possible in AWS for local configuration, for local IP configuration. If you see in the yes, VPC, the default range is this one, 172.31. This is, and normally you can take like 10.0.0 for your IP address range. My VPC. So I can take 10.0.0.0 by 16. So what does mean by this slash 16? Anyone? Amrita, you know what is by 16? Is this slash 16? No. So slash 16 means, see, this is first is 8 bit, 8 bit, 8 bit, 8 bit. And there is some, you can say some reservation for your network and for the host. And right side will go to the host. Host means your EC2 instance. Oh. Your application is the host, and this is for network. 16 means by 16 means here here slash 16 means it will reserve the first 16 bit. It will reserve this by 16 slash 16 means this will reserve this 8 bit, this 8 bit. So the variable will be this 8 bit and this 8 bit. You can change those addresses for this 8 bit. That means I'll tell you 10.0.0.0 by 16. That means this one is by 16. right? But this will be variable. Your network bits will be fixed, and this will be variable. So that means the IP range will be 10.0.0.02 10.0. This is fixed, and this can be variable 255.255. That means we can configure one IP range 2 to the power 16, and maybe your IP address may be I'll give you an example. I can give you an example. My range will be 1, then 2, then 3, or maybe okay, maybe 255. Similarly, it can be this is 1, 2, 3. Sorry, 1, 0. Right, and it can be range to 10.0.255.255, 2 to the power 16. Right, any problem understanding this? Because we are changing this bit, the slash 16 means this is fixed, and the remaining 16 bit can be used, can be addressable, right? And if I addressable means I can change this 2 bit. So I can provide 1 0 here, 1 here, 2 here, 3 here. Similarly, I can change to here 1, and then 0 here, 1 here, 2 here. Similarly, I can change this to 2, and up to I can change this one to 2 to 0 to 1 to 55 55, right? Any doubt here, Mitali?
No, no doubt.
Okay. So similarly, can you please tell me if I change this to 24, what will happen?
So three places will be variable.
No, 3
So
places will
that
be fixed.
one place will be variable, three
Yeah,
places will be
yeah,
fixed. Yes.
one place will be variable. Then total IP will be 2 to the power
2 to
8.
the power 8.
8. That means we can allocate 256 IP addresses. The
Yeah.
starting is 0 and the last one is 255. Right?
Yes.
Okay, this is the whole range. So I will create one VPC. So this VPC has been created for me. This VPC has been created, and after the VPC, I need to create subnet. Subnet, you can say combination of a subnet. You can say VPC, and under the VPC, I can create small modules. We can say that is subnet, and VPC is region specific, and your subnet is your availability zone specific. Like this way. This is your VPC, and inside this is the subnet, and you have to provide the small part of IP range to the subnet, and the small part of IP range to one subnet, and small part of IP range to another subnet, and this subnet will use those IP ranges for their EC2 instance. So let me show you subnet. So some default subnet has been created by AWS, but I will create my own subnet. This is my VPC ID, and I will create one subnet. Maybe this is my subnet. I can give this, and for this you need to prefer any availability zone. Maybe US 2A, and suppose I'm giving this IP range 10.0.0.0 by, see, two subnet cannot have any IP overlap. So if I allocate this IP range to this subnet, suppose I allocate this range of IPs to the subnet 1. So no IP, a single IP cannot be allocated to another subnet from this range. This is the rule. So I create the subnet. And this IP range means, I can allocate 255 of IP. Let me delete this. This means my IP range will be 10.0.0.0 to 10.0.0.255. Clear? This is the IP range. Suppose I am going to create another subnet. So what will be my next IP range? Can anyone?
What is your question? Sorry, I missed that.
Okay, I have already created one IP range, this one for a subnet. So my question is, what is my next IP range? What could be my next IP range for the second subnet?
10.0.0.0 by 16.
By 16, right? This one.
Yes.
But we have already allocated the this part.
Yes.
We have allocated this part. So we cannot allocate like this part already allocated. But if I see your range, this IP address also coming under this one. If I give this, it will give error
Yeah.
because this is already used. If I give this, it will definitely give error because this is already CIDR overlaps with your existing subnet. So my first subnet use this one, so the IP is overlapping. So what could be the next IP?
1 10.0.1 dot
Yes,
0 divided by 24.
yes, because this part is allocated. And if I change this 0 to 1, then I will have also this
Okay.
part.
Another
Another,
255.
yeah, another 256. So this will be right. So, but if I use this 20, let me use this 25 instead of 24 and I create. So this is used as 25, right? So again, I am going to create another subnet. Now I've created two subnets, then create the third subnet.
Nirmal, I could not understand the meaning of 25 here.
Okay, I will explain. Okay, please explain me what do you mean by 25. You can also tell me. You understood this one, right? Then what is the meaning of this one? That means uh, my first 25 bit is reserved. This is 8, this is 8, and this is 8. And also, 1 minute, also this one 8. So total 25. 8, 8, 8, and this is 1. And how many left? 7.
Yes.
25 fixed. Left is
Mm-hmm.
7. So 2 to the range will be 2 to the power 7.
Okay.
Right.
Yes.
maybe my subnet create subnet. This is already used. Okay, we have already created one. So I am going to create the third one. I think this is created already. 1 minute. Let me see. Let me check. VPC. This is the first subnet and this is the second subnet. For the second subnet, yeah, this is already used. Okay, Mitali, can you please tell me what is the next IP range? This is my first one. This is my first one. This is my second one. What will be the third range?
10 dot 1 dot 10.1 10.1 1.0.0.
24.
Yes.
No, you cannot use this one because your VPC, while you create the VPC, if I give this, see, there will be some error because your VPC range starts from 10.0. You cannot change this bit. You cannot change these 2 bit because your VPC range start from 10.0. If I give
Where
this, see, there will be definitely one error. My VPC. Your VPC range is this one. So you cannot give
yeah.
beyond that.
Okay, so
Yet
okay.
CIDR address is not within your address from VPC. So your VPC address is not is somewhat and you are providing some another range. So Sudhir, what will be the next IP range?
2.0.
Yeah, tell me.
10.0.2.0
Right.
by 24.
Mithali, is it correct?
Yeah, I think so.
This is correct. There is no wrong with this. For a better understanding, I can say this is not wrong. This is okay. But for better understanding, I can say this is by 25. That means you are having only the IP of 128. 2 to the power 7 is equal to 128. So our normal length should be, if we go, if you don't want to wastage any IP, so our range will be 128 by 25. The
I
file
get it. Can you
got.
please repeat?
So this IP range will be 10.0.0.02 10.0.12127. What will be this IP range?
Yes.
Right,
Yeah.
because this is 25.
Yes.
25 means 2 to the power 7. This IP range will be 1.0 to 1.127.
7
Right. The next IP range will be start from 1 to 28.
to 8.
Right. If I have written 26 here, right, then your IP range will be up to 63 and it will be start from 64. Right. So if I keep this, it will work. So this is actually for why I have given this is for understanding how you are going to provide your IP range for your VPC. Yeah, once you created one VPC, your VPC IP range will not change, but you can expand. Expand means you can provide another IP range. Suppose I have given one IP range like to my VPC like this one. Suppose I am given and this one by 24/24. That means 256. I will get 256 and AWS will allocate some 5 IP address and I will get maximum this 251 for one VPC. Suppose my instance has been increased and I need more IP address. What I can do? I cannot change the VPC IP range. In further, I cannot edit the VPC IP range. Instead, you can provide another range to the same VPC. Right? You can expand your VPC CIDR block by adding additional blocks. If you need a different CIDR range, create a new VPC. Suppose you want a different CIDR, you are not happy with this one. If you want a new CIDR, you can create a new VPC. AWS reserved IPs in each subnet. So while you are creating one subnet, right, and your 4 IP addresses in each subnet and the last one, the first 4 IP address and the last IP address reserved by AWS for their internal purpose. Maybe the first 4 IP is for base network, VPC routing, DNS related, and reserved for future use. This is the last IP. So for every subnet, 5 IP address will be allocated by AWS for their internal use. We will get the remaining. So if you check here, I've created some subnets and this is my first subnet. The range is 25. I should normally get 128 addresses, but I got 123. Similarly, here I should get 256 addresses, but I got 251. And similarly, in the last case also, we supposed to get 128, but we got 123. So we are just seeing less 5 IP addresses less what we allocated. So that 5 IP addresses is used by AWS for their internal purpose. Is it okay? Or any doubt? Mithal, any doubt?
Understood.
So next is your internet gateway. Internet gateway is a gateway through which your VPC communicate with the internet and with other AWS services. Internet gateway is horizontal scaled. This is fully managed by your AWS and this is a horizontal scaled, redundant and highly available VPC component. It performs the NAT, static one-to-one between your IPv4 address in your VPC and the allocated public or elastic IPv4 addresses. It supports both IPv4 and IPv6. You cannot SSS or connect to it. It is fully managed by AWS. This is a gateway. You can say this is a system, but it is managed by AWS. You cannot SSS or you cannot connect to that instance. And
So
this
what?
is, yes. Yeah, tell me.
What do you mean by horizontally scaled?
Horizontal scale, yeah, we'll learn about scaling. What is horizontal, what is vertical. We'll discuss that in the auto scaling chapter. You can say that scaled means
It increases.
yes, it increases horizontally means it mm, increases nodes to solve the load. Suppose you have given many loads, your system have some capacity, like maybe your instance have a capability of serving 1000 requests per second. But if you give 2000 requests, what will happen? You need more compute power, right? So this is horizontally scaled by AWS so that it can serve any amount of requests. We'll discuss about horizontally what is vertical scaling, what is horizontal scaling.
ଦେଖନ ଏଇଠି ସବୁ ବନ୍ଦ କରିଦେଇଛନ୍ତି ଯୋଉ ଇଏ
So next is where is the internet gateway comes. See, this is the VPC, and in the VPC we are having one subnet, here another subnet, and here range is 10.0.0 by 24. That means we are having three instances like 10.0.0.5, 6 and 7. Here also same 5, 6, 7, and we are having one elastic IP here 198.551.100. This is a public IP, and this is the private IP. Private IP, how you will identify a private IP? This is the private IP range like 10.0.0.0 or 172.31.0.0 and 192.68.0.0. This is a private IP range, and this is a standard RFC 1918 standard. So after seeing this starting 10 means this is a private IP. But for in case of public IP, that is different. And here is the internet gateway, and the internet gateway responsibility is to communicate to outside your VPC, maybe in the public, maybe internet access. Okay, then we will discuss your public subnet and private subnet maybe next time. Any questions?